There we go. All right, we'll get started. Thank you all for joining me for the next hour. I'm going to try to cram as much information about component building in an hour as I can. So if I'm going too fast, be sure to raise your hand. I can go back, cover some things. Any questions you might have, feel free to raise your hand. I'll kind of pull out some questions if I get to a stopping point, try to answer those. This is a huge topic. But it's one that I've been bringing back in the last a year or so in doing these events, because even though it's a topic that's been in Delphi since the version 1, there's some core techniques and things that you may not have been exposed to before. So formally, my name is Ray Konopka. I think recognize many of you. I have a booth in the back. I'm going to be here for the whole rest of the conference. So if you have any questions after the session, stop by, be happy to answer. I love Delphi, as you guys probably can imagine, and like to talk about it. Happy to delve into some of these details. But today is all about component building. So let me start. How many of you have built a custom component? Awesome, great. It is the workhorse of Delphi. Everything that we love and leverage from Delphi, from all of our application building, from components, from so forth, it all stems from the component model. And so I'm going to kind of show some of the history, some of the under the hood of how does all of that work. And more importantly, that if you are building your own custom components, some things that you should be considering that you may not have before. If you've ever run into problems with deploying your custom components or getting it onto another machine and why it doesn't set up as easily, all of these things I'm trying to address in the next hour or so. So jam-packed agenda, we're going to talk about the process. I'm basing this on my experience of building custom components. I build a lot of custom controls. And so there's a specific process, a specific order in which I do things. And that's really what I want to share, is some of that experience, some of those helpful hints to make your lives easier. We're going to talk about the visual component library. The VCL is the foundation. Now, anybody doing FMX development, any FMX component writers out there? So, great, that's fine. The principles are the same. It's the same component model. Everything that makes the VCL powerful makes FMX powerful. It just has more. And I'll touch on some of that as we get further along. But to get everybody started, we're used to the VCL. Let's see how that's architected. Because one of the next things that comes into play is what makes a good component? And if I have an idea for a component, well, what should I descend from? What capabilities do I need in that component? That's where we want to talk about the anatomy of a component. Like, what makes different features available to us? And what are the consequences of descending from one class versus another? And you may have run into this and not understood why you needed to do certain things. We're going to try to answer those through this session. I've got a very detailed example. It's detailed, but it's very simple. It's a very nice spinner control. It's one of my favorites I like to do because it touches on almost every aspect of component writing that's in Delphi. And if I had more time and I could do a workshop, I could extend the same component to add data awareness to it, to add image support through an image list, and collection support if I wanted to iterate through items. There's all kinds of things that we can do. But I want to get you started kind of that baseline of what makes a component a component. So that's where we're going to dig into these pieces. And then the final topic toward the end is effective package design. One of those gotchas that people run into. They've built a component, it's all working great, but they've run into problems the minute they try to deploy it, or they try to deploy an application that uses the components, and they run into issues with having some either duplicate units that show up, or packages that are missing when you try to deploy it. If you follow the guidelines I describe in this section, you won't have any of those problems. So let's get started. So the process. First, simple, really straightforward. We need to prepare for your new component. What I like to do, I'm not even worried about the Delphi IDE at this stage. It's like I've got an idea for a component I want to build. I want to create a new directory for it because I'm going to have support files and things that I want to put for it. I might have a collection of components, but even if I just had one, I have a new place to put it. And I create a test application. I do that before I even create the component. I do not worry about installing the component into the IDE until way later in the process. And so, which is a little different, that if you've ever run the component expert inside of Delphi, anybody ever try to use that? A couple of you have, yeah, nobody should, don't, it's terrible. It leads you down the wrong path and it's just a mess. No need to do it. All it does, it helps you pick which ancestor you want, but you have to know what your component needs to do in order to pick the right ancestor. It's a combo box, that's all it gives you. So we're not even going to worry about it. We're going to create a test application that we're going to use to dynamically test our runtime interface of our component. And in order to do that, we need to have a unit that defines our component. And so this is where I said don't use the component expert, just build a regular unit like you normally would. We're going to build a class that's in that unit that's going to be our component. We're going to talk about what that should look like through most of this class. And we create a new class with that name, following the standard conventions. Some things, just as you're thinking about names of components, you're probably not going to want to name your component T-button. There already exists a T-button. And so you're going to have potential collisions for that. One of the conventions that I recommend is coming up with a prefix for your own or your company's set of custom controls. And ideally, it doesn't collide with other controls. So that was why in the Konopka signature controls, formerly Raise components, that's through Gedit, they all have the prefix RZ from Raise software. And so that's what made it unique. So the TRZ button doesn't collide with the T-button class that already exists. Furthermore, your units should also have the same prefix, because as we get to package design, if you go to install a package that has the same name as another package installed in the Delphi IDE, it won't let you load that. So again, those are some things to keep in mind. So after I create my unit, I implement some methods and some things to get it working. Maybe I just have a brand new unit, doesn't do anything, just a new class. I'm going to dynamically create the component and test it out. Make sure it works. I can debug it. I can do everything I normally do with an application. How many of you have ever dynamically created a control on a form in your application? Yeah, most of you have. Or dynamically created a form in your application. It's the same principle. We're doing that exact same thing to test out our component without having to worry about any designer surface. We're not worrying about the object inspector yet. We're not worried about the form designer yet. We just want to see, hey, can our component be created and function on a form? So next step, once we've tested out the runtime interface, now we can start thinking about how do we get it installed into Delphi. And in order to do that, we need to register the component with Delphi. And so we need a register unit. Is typically something you have separate, not inside of your component unit. That's one thing you can remember, and that's another reason why I don't like the register or the component expert, is that it puts the register procedure in your component source code. It should never be there. Registration is a design time feature, design time functionality. It has nothing to do with the runtime behavior of your components. So create a separate registration unit for one or many components you have. And I will show, all of the source code that I'm showing is downloadable from my website, so you can see exactly how everything is structured and the way it works. But the benefit is we're going to create a registration unit. We're going to create a runtime package that's going to hold it. We're going to create a design package that's going to require the runtime package. So you will always have two. And I'll cover more of that when we get to the package setup. But we then build them. I'll show you how to do that. We'll go ahead and deploy it, and then we can install it. And installing is basically just going into the component install packages, navigate to the design package you want, install it, and we should be good. So we're going to go through all of those. That's the quick summary of the steps. Once we've got it installed into Delphi, it now shows up on our component palette. And once we see that, then we can drop it on our form and manipulate it with the object inspector and do whatever else we want. So, I know I'm throwing a lot of stuff in there, but some of this should be somewhat familiar for those who build components, but we want to get into the meat. So, first thing I want to do is do a quick demonstration of exactly this step, or most of the step, to the runtime process. How do we get started? And so, as an example, I'm going to switch over to Delphi 12, and I'm just going to build a new VCL application. Nothing fancy here, but I'm going to build a component. And as an example, how many of you have used a T-panel? Everybody's hand should probably go up, I would guess, if you've used it for any length of time. What's the first thing you do when you drop it on the form? Clear the caption, right? Every single time you go and clear the caption. And then what's the second thing you do? You go and find the border, the bezel, and change it to none. Because what do we use panels for? We use it for layout, was most of the time. The most common use for that panel is to lay out other controls, and we don't need necessarily the border in there, or certainly not the caption. Wouldn't it be nice to just have a component that's right there, and those two steps are done for you? Let's build one. So what I'm going to do is I'm going to delete that one. That's just a little sample. And let me go and create a new, I'm going to run this so I get that created first. So project 1, form 1, there's nothing in it yet. Great. Let me create a new unit. And so text big enough? You guys can all read that? Great. All right, so let's see. So TEmptyPanel, for example. I'm not doing a prefix. I know this doesn't exist. And so I'm going to make this just simply descend from tPanel. If you've done before, you're like, oh, you should do it. Blah. I know. We're just making this simple. And so what are some of the things that I would want to do? And so just to start, I'm going to override the constructor of this. And you guys have probably seen this constructor format before, so pretty straightforward. I'm building a class called EmptyPanel, descends from panel. Oh, well, where is panel? So I need to use vcl.ext controls, I believe. And since I don't have that, so let me go ahead and type this in, TEmptyPanel.create. Yeah, I know I could use the completion, but I'm old school. I don't like it because it doesn't put it where I want it most of the time. And while I'm talking and doing all of this, I can explain it. So call your inherited constructor because it's virtual. Great. Oh, where's component? Component exists in system.classes. So now we got component in there. And then, so what do we want to do? Well, let's clear out the caption. And bevel outer is equal to, what was that? Be none. That work? Oh, not in the panel because I deleted it. Back to here. Panel. Bevel outer. Oh, BV raised, BV none. Great. There. This. Panel bevel. Bevel cut in VCL controls. All right. I just control-click to make sure I found the right reference. So VCL controls got over there. Now I should have no syntax errors. Great. All right, fine. So I've got my component unit. All it's doing is just basically creating it, saying clearing out some properties, get myself ready to go. But now I need to do something with it. And so let me go ahead and delete that one. And I'm going to just, in the form create of this, I want to create a new empty panel. And so for here, I need to pass an owner. Well, who do I want to be the owner of this? Well, I have it be the form. That's the typical way that I would do that. And so, and then I need to define P, which I can make private or I can make it local. I'm going to make it private in case I want to do something else with it. So TEmptyPanel, of course, I need to have a reference to that. So then I'm going to add unit 2. So that's where the empty panel is defined. I should name that properly, but I'm trying to do this for speed, but you guys get that. The most important statement when you're testing runtime is this one, is you need to set the parent. The parent ensures visibility. So I can have it be owned, but if I go and create it and I don't tell who is containing it, who's its parent, it's not going to get the right notifications in order to render itself. So I need to tell it, hey, parent. Now, I'm using the form as its parent, but let's say I wanted to put this panel inside of another panel or a group box or something like that. You can change the parent to be another windowed control. And in about 5 minutes or less, I will talk about that in detail because it's an important distinction between the various types of components. And so I'm going to set the top, because I don't want it just in the upper left corner. So let's make it 100, and the panel right is equal to 200. And the fancy thing about this is I go and run it. One to the left. There's no right. So go ahead and save all these, run that off, and nothing shows up. Well, yeah, of course nothing shows up because I cleared it all out. I'm not changing the color. I got rid of the caption. So let me go and just comment this out for a sec and run it again. And there's my panel right in the middle. You guys see extra lines in there? Oh, a little bit. That's from the tiling of the monitor there. But this is where the panel is. So that is the foundational way to test a runtime component. And as you do things to it, what's really quite cool is maybe you wanted to add some behavior to try things like toggling the border. Okay, in your main test app, you can go and drop a button down and have it do something like change p.bevel outer to be, BV lowered. And so if we go and run that, and now I click on it, it changes it. So this is how you can test property interactions and things like that. Do all of your testing at runtime to make sure the component does what you want it to do. When you're satisfied, then we can worry about putting it into the designer, into the form designer. So, any questions up to that point? Excellent. All right, let me switch back to my slides. Gonna go deep into the foundational pieces of the VCL and what we want to do. And one of the core decisions we need to make really early on is, what do we want this component to do? And that will determine the ancestor that we need to choose. So, do we want to pick, are we trying to modify an existing control, like my example for the panel? It could be a button, could be a list box, you name it. You might want to inherit a bunch of functionality. Maybe it's something brand new. Maybe is it a non-visual component? Maybe it's just something you use to connect functionality with. All of these come into play. So these are the core ones that we're going to base our decisions off of, and we'll look at each one. Here's the whole hierarchy. Well, not whole. It's a fraction of the hierarchy, but highlighting these kind of main classes we want to be aware of. Everything descends from TObject in Delphi. And we have TPersistent. That allows it to be streamed, stored to a DFM file or a component stream. Our components are TPersistent descendants because components reside on a form that gets streamed out to a DFM file. The same is true for an FMX. FMX controls are TComponents. There's also a TControl that sits in FMX, but it's a different class completely than the VCL TControl. And that's our next level down. TControl, as you can see with the boxing around it, is a visual control. So things that are non-visual are like data source and timers, things, just have an icon on the designer surface. That's your distinction. So immediately, do I have visual or non-visual? If it's visual, let's go down to the left side, go to TControl. Well, then it's like, okay, well, what kind of visual control do you have? Is it a graphic control, which, as we're going to see, is really just kind of a graphical representation? We want to paint something on the screen. Or do we need interactions of some kind? And that's going to help us filter down. And at the bottom level, you'll see that we have these T-custom versions and then the T-non-custom versions typically. And it's a convention that I'll describe a little bit later on. So TComponent has some core features that every component gets, and it's very important. The first one being owner. And this is one of the questions Stefan had mentioned in one of the panels of memory management and how there's different ways. And you've got interface reference counting, and you've got manual, create and freeze and so forth. But then you also have ownership, which in the component framework, an owner will clean up all of its children. And so there's another mechanism, and that is handled by this owner property. So that's when we created the panel dynamically into the constructor, we passed the owner. Who's going to own this instance of the empty panel? Well, it was the form. So when the form goes away, you notice I did not have to clean up the empty panel instance I created. It gets cleaned up for me because I specified the owner. If I were to pass nil into the owner of the empty panel constructor, well, then I do need to manually free that if I were to keep going or have extra instance, kept the code going, not just exit. ComponentsList is another. The ComponentsList is basically from a component can own other components. And as you probably are gathering now, since everything was up at TObject and you had TPersistent, TComponent, you go TControl and blah, 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 there's a T-form somewhere down there that goes all the way up that gets back to TComponent. And so it has a components list, so it knows all of the controls, bad term, all of the components that it owns so that it can clean them up. There's some state, there's a component state property, which is very useful when you want to know whether or not your component is being manipulated at design time or not. So again, down the road, more sessions, detailed things, there might make sense to display something special if you are operating at design time. For example, a toolbar that has tool buttons on that have glyphs in them. But it might be nice to see the border of the button, but you wouldn't necessarily want those showed up at runtime, but you could put a dotted rectangle around the button at design time. So we can check if the designing is in the component state, then go ahead and do something special. There's a loaded method. Loaded method's interesting because it gets called after the component, the form, and all of its children have been loaded up from a DFM file. So if you guys have all built applications, you make changes in your form designer and it gets saved out to the DFM file. Well, the first line, if you've ever opened up a DFM, has that object statement for the particular control. It starts with the form and then it works down. Well, down in the controllers, you might have object P1 of type TEmptyPanel, and then you may make other changes to it besides what the constructor does. Well, when it gets created at the first line, it gets loaded, all that runs in your constructor. The other property statements get fired. At the very end, when everything is loaded, there's a loaded method gets called. So this is a good entry point if you needed to do something like autoplay a media clip is a good example. So you want everything to be loaded up, the rest of the forms all in place, and then you can look, hey, is autoplay turned on for my component? If it is, then go and actually play it. You'll know that everything has been loaded properly at that time. And then another key piece, and unfortunately I can't get into a lot, but I'll just mention it of how important it is the notification method. This is for component references. How many of you have one component that connects to another component through a property? There's a notification that needs to happen because ripped out from me. Well, the notification method is built into the VCL so that whenever the components list changes, it will call all the other controls and call their notification method so that they can clean themselves up. So if you just remember for component references, you really needs the notification method. That's the thing to look for if you're ever doing something to implement that. Okay, TControl. Okay. So TControl introduces the parent. So remember, TControl is our visual control. So it can be placed somewhere. It's visual on our form. So it needs to know who's going to be the parent. This is great. Makes a lot of sense if you have an edit box, for example. An edit might be inside of a group box, and the group box is inside of the form. Well, the parent of the edit is the group box. The owner of the edit's the form. So there's a little distinction there. There's also a control style. So any control that can be a container will have an accepts controls control style. That tells the form designer, oh, if you select a component from the component palette and you go and click on this control, if the control style has in it accepts controls, go ahead and create the component there and set its parent to who I clicked on so that it sets it all up. And then there's these others I'm not going to get into, but that's the more common one. TControl is where we start getting events, some event dispatch methods, some common ones, I should say. So like click and mouse down, things that we would do with a visual control. We're going to see these event dispatch methods, and I'll have a lot more to say about events and event dispatch methods in just a little bit. But this is where we start seeing these specific ones. Graphic controls are, as I mentioned before, a specific type of control that's on our surface. The key facet of it is there's no window handle. VCL is Windows-based, Win64, Win32, but it is still, whether it has a window handle or not, and that has implications. So you cannot contain any controls if you do not have a window handle. That's a requirement the way Windows works. So parenting requires a window handle. So a graphic control cannot be a container. So my little warning here, you can try it if you'd like and see what happens. It's fascinating. You can change, by default, graphic control does not have the accepts control style from TControl set. Makes sense that it wouldn't. There's no window handle. But since it's just a set element, you could add it and then drop your graphic control on the form, click and edit, and click on the graphic control, and Delphi will try to parent your edit onto the graphic control that has no edit, and Delphi doesn't like that for obvious reasons. So just as a little word of warning. Yes, I have done that, tried that years ago. It's pretty spectacular. Another cool thing that you can still get mouse events for your graphic controls, but they're actually coming from the parent. Actually, in the way it works low level, the graphic control is rendered by the parent. It's kind of hooks into the same process. So it's why we can get transparent graphic controls, which is quite nice. And there is a virtual paint method where we actually do our drawing with the canvas. So you have a canvas object that's inside the paint method that we override in our graphic control, and we can display and draw whatever we want for it. So it's great for things like charts and things like that. Again, not containing things. What is Windows? A TWindControl gives us a window handle. So a real Windows handle. And that gives us support for keyboard interaction. So once we have a window handle, we can now handle keyboard input. So arrow keys, letter key, your keyboard interactions. We can also support focus changes. So we can actually focus as well, because it might use the arrow keys to navigate. You're going to want to have a WinControl descendant. TCustomControl descends from a WinControl, so it has everything that we just had in the previous page, but it gives you a custom draw. So if you're what the common controls do, like a TEdit, it doesn't need to do according VCL styles with beyond what this session is, but typically you would ancestor. The first one was one that things, but this was one where okay, I want to set the caption, but this isn't just a field of an object. When I run this statement, what actually happens to the button? Well, the button's caption changes. It's re-rendered, it's redrawn to reflect the property change. And so the next piece is when we go to click that button, we want some behavior to do that. We don't want to actually create a descendant of the T button in order to tell it what to do when it's clicked. That's what you had to do for OWL and TurboVision and things like that. Instead, we want to delegate what happens when we click the button to have it do something over here, something else. And this gets handled by your form designer by default. You know, you double click on that button or the form and so forth, there's an assignment. That event gets assigned to some handler. Turns out it's a method pointer. The key piece, both of these things are supported by the building blocks of components. It's why they were rent. Go ahead and do a side effect. If they're the same, then you don't need to do anything. Why repaint the control or do anything like that? So most of the time you will just do that check and then set the internal value. So now the new value of it is what was passed in. And then we want to repaint the control. And the way we do that is called invalidate. There is also a repaint method that you will see if you type that in there, but generally that's not the one you want. It kind of depends on the control that you're working with. Invalidate's the one that you typically go to first. And as you dig more and more into it, you might want to do the repaint, which again is a kind of more advanced thing when you start having sub-regions of your component that are affected by it, and a repaint might make sense. For most, 90% of the time you're doing invalidate works just great. It tells Windows that, hey, this control, this window needs to be repainted. And so it puts the request in, so the next time the paint message comes in and gets processed, it will repaint this region, and this control gets the canvas paint method called, and we can go. Like I would an application handling a components event. It's internal, so generally you don't need to worry about what that does. So I'm going to skip through this because until you get to need to do that, we're not going to worry about it. So component messages are kind of interesting. This is an example where, because we're in the VCL, and like the enabled property and the visible property are defined at the TControl level. Okay, so there's a write access method way up in TControl for set enabled and set visible. But if I'm in a descendant class and I want to do something like paint myself differently if I'm disabled, well, I need to know that the control's been disabled. And set enabled is not virtual in the VCL. They're very rarely virtual access methods. I like making them virtual for extended that I'm creating, and we've seen this before, this same structure, no different. This is how I build the component. So the RK spinner, its owner is being set to the form, I'm parenting it I'm positioning it, I'm changing a color, and I'm setting an event handler called spinner change handler. And spinner change handler is down here that is simply updating the label, the caption coming from the value that's from that spinner control. So let me just run it real quick. And what we can see is, okay, here's the control. It's up here. My focus is on the edit, and if I tab around, it now has the focus. So when it gets the input focus, I have a little dotted rectangle that shows in the middle. Might be a little hard to see. But the key thing is, as I click on the control, it's updating. I'm changing the way the button looks, so I'm indicating that it's being pressed. It's all custom rendered. So I'm displaying the value, and then of course if I tab away, the focus gets changed. How do I make that? There's an event there, so if it changes, I can respond to the event change. So very simple, easy to understand control. It also supports the mouse wheel. It also supports, I didn't show this, let me tab over again. I can use the arrow keys, so up and down on the arrows. You get the idea. So this is the unit that contains the RK spinner. And so I have some enums for various values, which region I'm clicking on to do some work. But the general structure, if we look just at the class, we have some fields to hold various attributes of my component. So button width, the colors for up and down, what the value is, what's the current value of the component. So I need to know that. Some areas, I'm defining what do I want to do? I have an on-changing and an on-change. So on-changing happens right before it's going to change. So I can hook into that and say, no, don't allow the change to happen, and it won't. Once it's been changed, then the on-change event gets called, and we can respond to that, update the label or do whatever we wanted. Here's how you define some component methods. So if I disable the control, I want to know about it in this instance and change its appearance, make it all look grayed out is what it does. Here's an example of a window message. I'm hooking into the get dialog code. This is for me to tab into it and then use the arrow keys. Because normally if I don't do this, if you use the arrow keys, it'll navigate to the other focusable controls on it. So if you want to capture arrow keys, you have to do this method. This is all state change. Here's the paint. So I'm actually drawing on the surface. So I didn't show this, but this is a custom control. It has all these pieces I talked about. It's got focus, it's got keyboard operations. It's not containing any controls, but it does require the window handle, and it's doing custom painting. So custom control is its ancestor. These all for handling cursor, but this is helper support functions. That's why they're all in the protected area. Event dispatch methods, so whenever I want the change to occur, I call this so that it causes the event to fire. Here I'm interacting with the control. I'm overriding pre-built event dispatch methods that are defined in the VCL. So if I want to respond to when the mouse moves over it, well, I do, because I'm doing things as I track, and if I run that again, as I move it over, I'm highlighting the buttons, so I need to know if I'm in and out of the controls. So there's things that we can do there. Here are the right access methods for the properties. I don't have a lot of properties that are new to this control. These button color, the value, some things like button width, for example. And then I've defined the various properties that I want, and they're all in the publish section. And then follow the properties defines the events. Again, they're just properties, and they're just of the specific type. And then these are the inherited properties coming from TCustomControl that I also want to surface. I don't have the time to dig into the implementation of these pieces, but this gives you that guideline. You get the full source code for all of this, and so you can walk through and see exactly. It's not terribly long. Most of them are pretty straightforward. Your constructor, here are the right access methods I put up toward the top, kind of the newer things. And as you drill deeper in, you can see all that it does. At the very end is the painting and updating of the color functionality. We're still less than 700 lines of code for the whole component. So pretty straightforward. So any questions on that before I move on to the package organization? So I definitely want to talk about that before we wrap up. Awesome. All right. So a couple key things here. I touched on some of them before, but you definitely want to distribute your components in packages. You have to distribute them in a package in order to get installed into the IDE. But technically, I was able to use my TEmptyPanel, for example, without a package. So technically, you could deploy just the unit to your coworker and have them dynamically create the controls and use them. But that kind of defeats the purpose, especially if it's a visual control. You probably want to get that full experience and get it into the IDE in order to use it. So you're going to need to have a design package to do that. And if you're going to have a design package, create a separate runtime package. If the one thing that you can remember from this section is to never do the combo runtime design package, which is what Delphi likes to create by default. And it drives me insane because it won't work for you when you want to deploy it to a customer who does not have Delphi installed. So if you were to build an application that used runtime packages and you try to deploy your design time runtime package to a customer that doesn't have Delphi, they don't have the design packages that are required by your designer combo. And it won't load. And they get an error, and it's a really funky error. of what shows up. It's something's not available, and it's this little designer unit. And because it's not even deployable, it's not a deployment issue. It's Embarcadero doesn't let you deploy that design package because it's licensed to your Delphi installation. So that's why you need to separate runtime and design time. So remember that will greatly help you. And then, as I mentioned before, registration, there's a registration unit. There's a register components method that you call. And I didn't do that here, but if we go into the source of the components, so conference components, so raise samples VCL is what you'll see. That'll be the download. And inside of there is the full structure. You get all of this. So the different DPKs that are required, those are the packages. And there's a registration unit. So inside of the registration unit, you're going to have some base classes you bring in and any design editors, which I didn't show any here, but then the components. So here's the RK spinner unit that gets referenced as in the uses clause, and where it gets installed is in the register components call. This is where you specify the component palette page that these controls will show on. So that's why this is saying raise VCL samples. They will show up under that palette page, and here is the order in which the components will be displayed on there. So you first have the regular spinner. Property editors, component editors are registered in a similar way. This is why I isolate. This is all designer stuff. It doesn't need to be in your runtime code. So, going back to the slides, the structure here, I just talked about it. So registration units, created separate, registers all of your editors, your components, and so forth. Your runtime package will require the RTL typically and the VCL, the core runtime package that's there. If you build something, you build your package and you see references, some unit was implicitly included into the package, that you should always, even though it's a warning, you should really consider that as an error. That means you should be requiring some other package in your package. So if you build it and you see, unit classes is implicitly imported into your custom package, wrong. You missed the VCL runtime package. So set that up. There's a way to leverage the lib suffix define the directive that tells your package to put the right number of the VCL version you're using at the end of it. Because you can have multiple versions of Delphi installed on a machine, and you want separate versions of those packages, both runtime and design time, so that they work, because their DCUs are different between the different versions. I like to include the version number into the package resource. So it's just a version info, like a regular Windows resource. So have your version of your application or your package included in there, but not necessarily in the name of the file. Because then that gets overwhelming when you try to do updates, because then the old package is still there. You just want to replace it. No design time features or registration should be in your runtime package. And then you would typically install these somewhere on the system path so Windows can find it. The Windows program loader will navigate its regular structure, current directory, comment, the search path, to find any DLLs. A package is a special DLL. So it follows the same rules and guidelines. So typically, everybody would install it in the System 32. That was the current directory. Well, now it's depending if it's syswow 64 system, whatever, blah, blah, blah. You're not going to do that. That's highly not recommended anymore. Adding a new search path or adding it to the one that's built into Delphi where it has under the public documents folder, there's a directory for BPLs. Typically, if I'm building custom ones internal, I have just a new directory that I put all my runtime packages in there. So it's kind of old. I don't have to have like 5 different directories added to my path. I just have a runtime packages directory and add it there. Your design packages, this has the design functionality. Your design packages will require the runtime package. The component that you just implemented is implemented in the runtime package. Your designer is simply adding on to that. So it'll require the runtime package, And it'll add in all of the design editors. It will require the design packages that come with Delphi. And that makes sense because the only people that are going to be loading your design package are people who have Delphi. So you only deploy the runtime package to end users. Other developers in your organization, or external if it's third party, you would deploy both to another Delphi user, just not the end user. Avoid installing your design packages into the Delphi bin directories. Make your own bin. So under your own install, have a bin directory there, and that's where your design packages go. That does not need to go on the system path because the full path to your design package is stored in the registry by Delphi itself. I got 1 minute. Perfect. So all the code for the packages is included in that same list there. And if you have any questions about how that's structured or why it's set up the way it is, feel free to reach out, talk to me, send me an email. I'm happy to answer questions on this. If you have questions now, I have 30 seconds, so I can't answer them at this moment, but I will be back at the Raise Software booth and happy to entertain any questions you have. Sorry for talking so fast, but I wanted to share a whole lot of information, and thank you all for attending the summit.